Hi everybody, this is Eric from the Right Click Save project, and you're watching the first video in my new RTFD series where we will be reading the fun documentation of the Solidity programming language. And now we're going to start with the latest version as of this recording, which is 0.8.19. And essentially, if you understand all of this, I'd say that basically makes you 80% of the way there to becoming a in-demand smart contract developer. The rest just being a matter of practice and experience, but essentially any Solidity tutorial that you go through these days are basically rehashing this information. Obviously, reading documentation can be boring and sometimes difficult, so hopefully these video walkthroughs will be useful and we can save a few bucks on tutorials. So we're going to start with the basics. Now, they are giving us a couple of smart contract examples. We're going to do one today, and then in the next video, we'll go over the other one. So let's start with our storage example. Good thing about these documentation, they have these handy links where we can open something directly in Remix. And if you're not using Remix as a blockchain engineer, you absolutely should be, because it is a wonderful tool and is super helpful. So now let's start. Here we go. So this is a pretty bare bones contract. Line 1, we have our license identifier. If you want to share the code, this is important to have. It won't break the compiler. It's just a comment, so it's not actually read by the compiler. But if you don't have it, it might throw up a warning and it'd be kind of annoying. Now, line 2 here is a little more important. It's called a pragma statement. And this gives our Solidity version. So right now we're using anything greater than or equal 0.4.16 or less than 0.9.0. This basically tells the compiler what version of Solidity you're using or what version of the compiler to use, because if you're mismatched between your compiler and your actual code, it can cause us some errors, because Solidity is a very rapidly evolving brand new language. They have new features all the time. So if you want to avoid errors and breaking changes, then you have to make sure your pragma statement is in place. Now, the rest of this is the contract itself. We have our contract keyword, which tells the compiler that we're about to define a contract. We can name it whatever we want using Pascal case as a convention. So I recommend sticking with that convention, and everything else in between these brackets is the as a definition of your contract. So we have two essential pieces here, which is state on line 5, and two functions which allow us to access or manipulate that state, basically interact with that state. And that's essentially what a smart contract is. So let's start line by line. Now, line 5 here, we have uint stored data. Now, this uint keyword is one of the data types that we will be learning, and it stands for unsigned integer. Now, we can go further depth later. Unsigned meaning no negative values. It's just 0 and anything, higher than 0. And we're naming this value stored data. And this is what's actually going to be stored on the blockchain, is this value right here. Now we're going to have a getter and setter function. Our set function is going to allow us to put a different value into stored data. So this takes in a parameter, another data type of uint, and the variable name is going to be x. And the public keyword just means that we're making this function available to pretty much anybody who wants to interact with this contract. Could be another person, could be another contract, could be a contract that is derived from this contract. And again, we can get into inheritance in later videos. But basically, all we're doing is we're taking that stored data variable that we defined up on line 5, and we're setting it to a new value of x. And by the way, this will automatically have a value of 0, even though we did not explicitly define it like this. Solidity will do that for us. They will give all our variables a default value. Now, in the case of uint, that default value is going to be 0. Function number 2 is our getter function. We call it get. It is also a public function. This view keyword basically signals that we're not changing any state. We're only looking at state. And this one also returns a value. Our first function set did not return a value. Our next function returns a value, and it will be of type uint. Now, if you're coming from a programming language like C++ or Java, keeping track of your data types is nothing new. But if you're coming from, say, JavaScript, it's going to take some getting used to, but it is important in Solidity that we accrue track, that we define variables with a data type, and we explicitly tell them what we're going to return. So just something to get used to. And now here in our get function, we are returning this whatever's in stored, whatever value is stored in our stored data variable. And that's basically it. This is a very bare bones function, and we're going to compile it now, and we're going to deploy it within Remix. So this is not deployed live to any mainnet, but again, another reason this is a great tool that we can test things like this. So like I said before, stored data should default to 0. So if we call get, it's going to get us 0. And if we call set, we can pass in, say, 5. Now when we call get again, it's going to give us 5. So we're able to set our variable with this function, able to get it with this function, and this stored data will, if this was a deployed live contract, this stored data variable will persist to the blockchain forever. And that is it. We will go into our next function. I'm sorry, our next contract in the next video. I hope you enjoy this. I hope you found this helpful. My name is Eric, and I work for CryptoPunks.